Okay, this lecture is over Chapter 10 of your textbook, and its title is Classes and Object-Oriented Programming. So some of the topics we're going to be talking about are procedural programming, which is probably what you're used to doing, and what is object-oriented programming and how is it different than procedural programming. Related to objects, we'll talk about classes and instances, and then we'll talk about what I would call some tips for designing your classes for your various objects. So when we write procedural programs, they operate on data types that would be like integers, floating point numbers, arrays. If we need to pass data into a function, we pass that data through the argument list and that type of thing. And kind of the focus is writing procedural programs. That is what I would consider normal programming. Object-oriented programming, we have this abstraction that we refer to as objects. And the object is kind of a container that inside that container there are data, pieces of data that we're going to use that are related to the object. And then we have what they call procedures. We would probably call them functions in a procedural programming language. But in object-oriented programming, we're going to refer to those as methods. So methods are going to be things that you call that ask the object for information or ask the object to do something. And then it will manipulate its internal data structures to do whatever you ask it to do. This combining of data and code into a single object is referred to as encapsulation. You encapsulate those things and for the most part hide the internal contents from the programmer that is using your object. They have data attributes here shown as squares, and then they have the little circles with arrows that represent code. So you call a method, and then that method will interact with the data attributes and possibly call other methods within the object. Data hiding is the fact that we're hiding data attributes and code from the outside world. So that protects it from accidental corruption or bad programming style where you're trying to access those data attributes directly, worst case is a global variable. So it kind of puts more structure, if you will, on the data attributes. And the other thing is somebody using the object doesn't need to know anything about it. Doesn't need to know how you store the data. It doesn't need to know how the methods operate on the data. You just, if written correctly, you just call the method and the object does what you ask it to do. Another concept related to object-oriented programming is this concept of object reusability. So if you create an object that describes a car for some project you're working on, you or someone else might be writing a program that is manipulating data related to cars, so they can potentially take your car object or your car class and they can use it themselves and reuse it. And since all the data is hidden and you don't interact with the data attributes directly, it's going to work very, very easily. If you call the methods correctly, they're going to manipulate that car object or instance the way it should. So this is that data and attributes and code picture again of an object. and it's just showing that you call the methods in the object from the outside. So you'll need to know the method name and what arguments it needs, but other than that, you don't need to know anything else about the object. So, they're giving you some examples here. If you have a clock, 3 of the data attributes might be what hour is it, what minute is it, what second is it. So those are going to be attributes or data attributes, they call them. Then you're going to have some public methods like set the time, set an alarm time. I'm kind of surprised they didn't show this. This is setting things in the object. You also have get methods that would be like get the current time, get how many alarms I have set, get the times on alarm 1, that type of thing. And then within this object there may be private methods that we may not even know about, but if we do know about them, we can't call them directly. Only other methods within the object are able to access its private methods. A class is a definition. They equate it to 2 things. They say, a blueprint is a drawing of a house, and from that blueprint you make a house. Or you have a cookie cutter that outlines a cookie, and then you use that cookie cutter on dough to actually produce a cookie of that shape. So the class is the blueprint or the description or the definition of the object. An instance is actually an instantiation of the object. So going back to the blueprint, if we have a blueprint and we use that to build a house, that house is an instance of a house. Maybe we live in what is often called, not to mix up the analogies here, but what's called a cookie cutter neighborhood, which is where they build 50 houses that are pretty much exactly the same. So from one blueprint, you created 50 instances of houses. From one cookie cutter, you might cut 20 cookies out of a sheet of dough. So the instantiation or the instance is actually the object that you're using. The class describes that. And I gave you both examples there, their last statement, which is there can be many instances of one class. So here they're showing you a blueprint, and from it they've built 3 houses. So the blueprint is the class. The actual houses are the instance or instances. The other thing we can do is we can, in one set we have an insect class that describes an insect, and we can make one instance of that class and have it describe a housefly, and we can make another instance of the class that is talking about a mosquito. We'll see something similar to this a little later that's a little more involved. So the class definition is, like I said, the definition of the class. The way you do this in your code is you have the keyword class followed by what you want to name the class, followed by a colon. And they're saying it's not required, but it's kind of de facto standard, if you will, that class names often start with uppercase letters. The method definitions are pretty much the same, with the exception that when you call methods, there's this thing called self. It is a parameter, and it basically references the current object. So it's yourself, if you will. And a lot of times you'll say self.method to call one of your internal methods. All classes have an initializer method, which you can kind of see it here, maybe if you squint, but it's 2 underscores, INIT, 2 underscores, and it takes one argument, which is referred to as self. And this is usually the first thing you define because it's going to tell how to initialize the objects. And a lot of times this initialization is defining your variables and maybe setting them to some initial value. So here's an example. We're importing the random library. We're defining an init method, and what it's doing is basically within self there is a variable called side up, and we're going to start it out as being set to heads. We're then going to have a toss method that, if we call it, is it's going to generate a random value, 0 or 1, and if the value is 0, it's going to set that side up variable to heads. Otherwise, it's going to set it to tails. And then here's one of those getter methods. Get underscore side up is going to return the current value of the instance's side up variable. So it'll return whether it is currently set to heads or tails. If you need to create a new instance of a class, you're going to say variable name equals and then the class name and then parentheses. So here's an example of where it looks like you have a coin class and you are creating a new instance of coin, and you're going to refer to that object or that instance as my underscore coin. And what that's going to do is it's actually going to create that instance, and it's going to call its init method to initialize the object for you. So this is just showing you that in a picture it creates an object, which they're just showing as a rectangle. They're calling the init module, which is going to set it to heads, and then basically they're showing that within that coin object you now have a variable that is set to, in this case, heads. If you want to call a method within a class or within an object instantiation, you're going to use the name of the instance or the variable that we're using to refer to the instance, dot the method name, and then arguments. So the reference in this case to self is passed automatically because it's required. So here we're creating a coin, we're tossing the coin, and then we're printing out is it heads or tails. And down, that's all I'm going to say about it, but line by line it's kind of telling you what you are doing, but we've talked about that already. The data attributes should be private, and the way we make a data instance or a variable private within a class is to put 2 underscores in front of the name. So we would really want to use underscore underscore side up so that it is private. That means only things within the object instance can reference or look at or alter that variable. A lot of times your class files, your classes are stored in module files, and they have a name. Often that might be the same as the class name, and it ends in .py for Python. And if you choose to do that when you write a program that's going to use those classes, then you're going to need to import that like you have been doing some other libraries, like the random library, for example, or the turtle library. Here they're showing you some additional examples. This one is going to model a bank account. So what happens is when we create the account, the bank account object, it's going to call the init method, and then it's going to create a private variable called underscore balance. And then there are going to be some other methods that you can use to do common things to a bank account. Here they're mentioning that you might have a deposit method, which I assume would take a dollar amount and then it would add that to your current bank account balance variable. There are some predefined methods like underscore, init, underscore. There's one called underscore str, underscore, and its intention is to display the current object's state. And in this case, what the state is going to be the balance of the bank account. So here we're going back to the coin toss, and they're showing you that we've defined a coin class. We've instantiated 3 instances of the class, coin 1, coin 2, and coin 3. And then we call toss on each of those, and randomly coin 1 is now tails, coin 2 is now tails, and coin 3 got set to heads again, so it stayed unchanged. So the toss method is just one of those methods we do to ask an object to do something. There are what Python calls accessor and mutator methods. A lot of programming languages, for accessor, they use the term getter, and for mutator, they use the word setter. Apple's object-oriented programming languages like Objective-C and Swift, if you read about those, they're going to call them setters and getters. But an accessor method you use to access something, and it doesn't change the value, it just tells you the current value. So like, telling me is the coin head or tails, that's an accessor method. A mutator is going to change it. So, if you say something like set current time to this time, that's going to actually change the associated data attribute when you call that method. As far as arguments, a lot of the things we've done I think have been kind of integer, floats, strings mainly, maybe dictionaries, but you can actually use objects as arguments to call, and when you do that you're actually passing a reference to the object, or other programming languages call it a handle, so that you can reference and go, hey, you object X, do this. And that object X would be the reference to the object that you wanted to ask to do something for you. They talk about something called Unified Modeling Language, or UML diagrams. This is a way to symbolically show information about your classes, and therefore about instantiations of objects from that class. And they're going to look like this. You're going to have 3 boxes. The class name is going to go in the top box, the data attributes are going to go in the middle box, and your methods are going to be listed in the bottom box. So here for coin, they have the class name as coin. We only have one data attribute, which is private, and its name is called side up. It's going to have that init method that all objects have, and then we've talked about a toss and a get side up method. So this is the UML diagram for our coin class. And when you get familiar to looking at these, if somebody gives you one of these, you already know a lot of information. You know the class name, you know what data attributes it has, and what methods. And if the person did a good job of naming the methods, you probably already kind of know what the methods are going to do, or at least you can make an educated guess. So one of the first things you have to do, if you're not provided with the objects to use in your programming, is you need to develop or design these. So they've come up with a way to do this, and basically what you do is you write everything you know about the problem, and this can be a bulleted list. You then look for all the nouns, and then what you do is there might be similar nouns, like, maybe you have car, maybe you have sport car, maybe you have old car, classic car, and then decide, well, I can really convert all those into a class just called car. So you eliminate any redundancy in that, and then you convert or consider all those nouns for potential class names. And then, the redefining is what I talked about, cut it down to a bare minimum. Then they're giving more information before we go to the next step. So, you might write this, or you might have an expert in the field writing this to give to you as the programmer. So, what are the roles of the object? What's the business event you're trying to cover? What record keeping do you have to do? And what physical objects are you trying to represent? So those would be nouns or pronouns. Like you said, there may be redundancy, like I gave you an example of. Then what you're going to do is eliminate the nouns that have the same meaning, which is what I talked about, and then remove nouns that represent items that the program does not need to be concerned about. Maybe somebody talked about putting cars in garages, but the problem you're trying to solve has nothing really to do with garages. That was just extraneous information, and you can remove those. You can remove nouns that represent objects. And then you can remove nouns that represent simple values that you're actually going to assign. You might have said something like classic cars or cars made before 1980. Well, you might just define what year is this car, and then put that 1980 reference, if relevant, into your program code. You need to know what the actions are within the class. This is going to help you define what the class methods should be. Again, you're going to go back and look at the problem domain and look for required actions, and then convert those into method. So that finishes up this chapter, the Intro to Object-Oriented Programming. And here on the summary, it kind of talks about what we did during this chapter. And like I said, that is the end of the chapter. So that finishes up chapter 10.